Hello and welcome back to the second episode kind of in this Python learning series with AI. I am super excited to bring you today a lesson where I'll be walking through how you can learn an idea in statistics. Statistics is having a profound impact on the world today and has in many ways throughout human society altered the way that many people interact with the world. Especially important today is the amount of observable data. So with the increase of the digital advent of all this technological devices, smart technology, IoT, things like cloud is what it really allows our systems to have is the vast amount of data, which provides feedback for people to run statistics on and do analyses like data science and things that allow us to have insights before that we might have not had. And so what I'll be exploring today is how to use artificial intelligence to supplement your learning, a common theme on this channel. And then again, to be looking at two fundamental ideas in statistics. So first of all, normal distributions and also known as Gaussian distributions, named after a famous mathematician. And then also we'll be looking at the law of large numbers, which is a fundamental idea um, related to sampling and how the data changes as you accumulate more data, like I was aforementioning with our digital age being important to kind of scale up the actual amount of data that we're able to look at. And so looking right here on the left, I encourage you, if this idea can be applied to any kind of general learning that you want to do, but I encourage you if you were wanting to learn something, first explore the Wikipedia page, as there likely would be a Wikipedia page for the idea. And so if we look here on the normal distribution, we can read a little bit more about the normal distribution and why it's important. So like I was saying, also known as the Gaussian distribution, characterized by this bell curve. We see it all the time. We see it in test scores. We see it in so many places. And then we also have this cumulative distribution function, essentially representing the accumulation of the probability events as we progress along the density function. So this is actually the integration of the density function. If you're not familiar with statistics, and integration is just the accumulation of the area under the curve. And so as we're looking at this, we get to see some popular ideas on the side in the Wikipedia we can explore, things like the support, the parameters, things like mean, the variance, and then we can also read a line here. And so the central limit theorem is very similar to an idea, another idea that's very important, and all these things are very important. I'm not going to read through all of these things, but normal distributions is essentially showing you how a lot of natural phenomena, their statistical likelihood of occurring, and their presence of how that data is distributed throughout the world. And so I guess I will talk a little bit about the central limit theorem. So it's essentially saying, it's stating that under some conditions, an average of many samples of a random variable with finite mean and variance is itself a random variable whose distribution converges to a normal distribution as the number of samples increases. And so this is kind of relating to the law of large numbers, where as you increase your sample size, you actually see a convergence into a normal distribution, which is one very famous in nature, which is why a lot of natural systems we can collect data on and observe them as Gaussian or normal distributions. And so we're going to look, so there's a little bit more on the Wikipedia page. You can definitely explore about some applications and relationships with linear combinations, some ideas in linear algebra, things like this from your high school mathematics course. Also a little bit more definition about probability theory. Also the general normal distribution, how we can have a shifted function from this general normal distribution to make our lives easier for some of the mathematic notation and mathematic computations of things, like actually computing the probability of being um, within a certain region of our probability density function, or with the cumulative distribution function for certain mu and sigma, or average and variance. Average being the value in the average being showing what's not essentially the middle, but representative of what we would like be centered around. So the Gaussian distributions, another property is they're symmetrical. And then variance kind of representing how spread it is. So a variant, the blue you can see has 0.2 as a variance, and the red has a 1.0. So a variance, or sigma squared, represents kind of how spread out the data is. So with that in mind, I'm going to open now the artificial intelligence prompts that I kind of did earlier with ChatGPT 4 in the Bing browser here, as you can tell. And so what I essentially did here is I really encourage you to think about where you can have multidisciplinary learning. And so here I explored the statistical ideas in Python 3 in a package called Jupyter, which is in the Anaconda software suite. I will link that in the description of the video so you can install that. So we're able to do plotting. So I first prompted it, can you generate code for me to plot a Gaussian distribution in Jupyter Notebooks? It does all of this. It talks a little bit about the packages, the actual code itself. This hashtag is defined in comments. It talks about the documentation, the libraries used. So scipy.stats to get the normal. Essentially the numpy populating the data across the sigma range, 100 points with NP linspace. And then I actually do the plotting. It just gives us the code. I ran the code, and what do you know? We see a nice Gaussian distribution with a mean of 0 and the sigma of 1. And that's what this essentially looks like as they populate it here. And then what I moved on to was, so say you have a concept that you wanted to clarify. One of the beautiful things is that this can act as like a tutor. And so illustrating the concept of the law of large numbers here, I prompted it to give me some code to contextualize the idea. And so here, one of the beauties, once again, multidisciplinary learning. So not only learning a concept like law of large numbers, but being able to cross understand that with code and learn code at the same time. And so what this is essentially doing is it's showing the importance of law of large numbers. So like I aforementioned, law of large numbers works on kind of experimental scenarios where we're accumulating lots of data. So here, if we walk through the code, we first import our libraries we need, and we defined our distribution parameters, the number of samples we want to generate. We calculate the cumulative mean of the samples. The samples is an actual list, and so we're doing a cumulative sum across those samples, and then we are doing uh, looking at the cumulative mean. So as we go on, what does the progression of the mean look like? And as we can see, it converges to a kind of fixed point here, almost coming to 0, which is what we would expect, because that's how we define the distribution parameters. And so that's the law of large numbers. It's essentially, as we collect more data points, the mean will be reflected in the actual mean of the data set. So essentially, more data equals better. And that's what we like to do in a lot of kind of bio life sciences scenarios. And so it talks a little bit about the actual code here. It says, I hope it helps in a friendly manner, which is kind of enthralling and a little bit scary. And then I asked some examples, and so it gives some examples of the law of large numbers, such as life insurance to model the likelihood of death for essentially determining what the premiums of policyholders, very interesting. And then things like polling. So one motivation behind this channel is that the election is coming, and it's going to be probably crazier than it has ever been before. And so polling is another place the law of large numbers. So we can survey a sample large enough to see with a high degree of accuracy the average, kind of similar idea here. And then applications in finance, like diversifying your portfolio, making sure that you're not risk averse by exposing yourself to a large amount of data and changes and within that. And then okay, the next prompt I did was, what is the Gaussian distribution? Why is it important for our lives? So it talks about a little bit like test scores, more things like roll of two dices, natural phenomena like age, and it defines this thing as parametric statistics, Gaussian distributions, modeling parametric statistics. And then it talks a little bit about, I guess, the mean limit theorem, the central limit theorem, things like this. Another interesting thing is financial returns and height in populations. Cool. And then it talks about things like clustering algorithms, things that you could explore more in detail if you would like. And then, yeah, this is a little bit actually out of order. And so the last thing that I did was I wanted to try to do an animated plot, and this was something that I failed in, but I got the code here where I was trying to generate an animated plot, and it, interestingly enough, generated an example of the weak law of large numbers. So weak law of large numbers would just be not having that much data, but seeing some convergence. And so the example they did, interestingly enough, this is super cool, but imagine you're rolling a dice. You have numbers 1, 2, 3, 4, 5, 6. What are the average of the what are the expected outcomes that we could get? We could get 1, 2, 3, 4, 5, or 6. Add up all those numbers, you're going to get 21. Divide that by the total number of possible outcomes, and you get 3.5. So 21 divided by 6 is 3.5, and that's what we would expect for to be the mean in a uniform distribution. Uniform being they all have the same likelihood of happening. And interestingly enough, you can kind of even start to see the law of large numbers with the weak law even after 8 to 9 tries. And so that was all I really had for this video. I hope you enjoy. The law of large numbers and Gaussian distributions are a huge part of our lives. Have a wonderful rest of your day, and I hope to see you in the next one. Goodbye.